Ayaw mo gano'n. Ilabas mo yun, ano, nawawala, eh. Keep on changing their location, motion, physical appearance, skin reaction to different chemicals, height, weight, hair color, eye color, ideas, and even values in life. Usually, the heights of a group of people with the same race tend to converge
Well, President, come out. All right, we're here at the firehouse. Thank you, guys. Here we are. Here we are. Yeah, at the firehouse.
Excuse sir, wala po kaming narinig. Sorry po.
Excuse me, sir. Di ko po naririnig, sir.
Sir, wala pong audio, sir.
Wala pong audio.
Formula
Leave.
one. Our topic for today is about measures of variation. So, events of nature vary from time to time. So, people keep on changing their location, motion, physical appearance, skin reaction to different chemicals, height, weight, hair color,
Okay na
eye
po.
color, ideas, and even
Okay na.
values in life. Usually, the heights of a group of people
Yes, Dean.
with the same race tend to converge to a certain commonly or common value. So, for example, if the mean height of Filipino males is approximately 5 feet and 6 inches, then this means that the most Filipino male adults have height that are clustering about this value. The extent of the clustering of the height of the Filipino males about a central value is known as variation. The measures of variation will enable you to know how varied the observations are, whether there are extreme values and the distribution, or whether the values are very close to each other. If the measure of variation is zero, it means that there is no variation at all, and that the observations are all alike, or homogeneous. Otherwise, they are heterogeneous, no? So the common measures of variations are the range, mean absolute deviation, variance, standard deviation, coefficient of variation, quartile deviation, and percentile range. Now, so when we say measure of variation, it is used to determine the scatter of values in a distribution. So to get the range, we need to subtract the lowest score or observation from the highest score. So here is the sixth measure of variation as I mentioned earlier. So the range, quartile deviation, mean deviation, variance, standard deviation, and the coefficient of variation. Okay, again, the difference between the highest and lowest values in the distribution is what we call range, no? The simplest form of measuring the variation of a distribution. So this will be the formula. R is equal to highest observation deducted by lowest observation. So we have what we call ungrouped and grouped data. So we start with ungrouped data. Subtract the lowest score from the highest score. So example number 1. A group or find the range of distribution if the highest score is 100 and the lowest score is 21. So for us to get the range, what we're going to do of course is to replace now the highest score, that is 100, and the lowest score is 21. So 100 minus 21, that is 79. So therefore, based on the given example, our range is 79. Example number 2. A group of scientists went on an expedition to the mountain range in Bundok Arayat to study the different species of plants existing in the area. The ages of the scientists are as follows, no? 34, 35, 45, 56, 32, 25, and 40. So, what is the range of their ages? So, as what we have here, based on the given formula a while ago, what we're going to do first is to find the highest. So, the highest age, of course, is 56. Okay, 56. And of course, the lowest, no, the lowest age is 25. Okay? Now, direct substitution. So, range is equal to highest, that is 65. then deducted to lowest, that is 25. So 56 minus 25, that is 31. So therefore, the range of their ages is 31. Okay? So we may proceed to the mean absolute deviation, or MD. So to find the MD, or mean absolute deviation, subtract the mean score from each row score. Then using the absolute values of the differences, get the sum of the results. The sum is called the sum of the deviation from the mean. The next, divide this sum by n, the total number of cases. So we have a formula here in getting the mean absolute deviation using ungrouped data. Okay, so this will be an ungrouped data. So MD, or mean, is equal to summation of absolute x minus mean, no, over n. Where where mean, or absolute mean, is equal to summation of xi over n. Okay, where MD, mean absolute deviation, X is a row score, and of course there's a symbol, the X bar, mean score, and N is a number of observation. So how about for group data? So this will be the formula for group data. Okay? So as what we have here, MD is equal to, of course, mean absolute deviation. F is a frequency, no? Then X is equal to class mark. The X bar is equal to the mean score, and N is the number of observation. So a while ago, we have a group data formula. In this time, this will be our group data formula in getting the mean absolute deviation. Now, example. Take the mean absolute deviation of the ages of the scientists in example number 1, as what we have a while ago. So the ages are 34, 35, 45, 56, 32, 25, and 40. So what we're going to do is of course, direct substitution. So x sub 1, that is 34, x sub 2, that is 35, 45 for 3, 4 is 56, 32 for 7, 8 is 25, then 40. So 1, 2, 3, 4, 5, 6, 7. Sorry. So 6, 7. So therefore, if we're going to add this value, so we get 267 over 7. Sorry, it says 7 because we have 1, 2, 3, 4, 5, 6, and 7 only. Okay, so 267 divided 7. Therefore, our mean absolute value or deviation is 38.14. Okay? Okay. So, this one, as what we have here, so MD absolute deviation is 7.59. How about the variance? No? It is another measure of variation in which can be used instead of the range. So the variance consider the deviation of each observation from the mean. Okay? So to obtain the variance of the distribution, first square the deviation from the mean of each row score and add them together. Then divide the resulting sum by n, or the total number of cases. So we have here a formula for population variance for an ungrouped data. So we're in this population variance, no? So this population variance, no? This is for population variance. X is for row score. This one is a population mean and the number of observations. So this will be the formula for population variance for ungrouped data. Now, so sample variance for ungrouped data. A while ago, population variance. This time, sample variance. We need to take note that sample of course, is of course, as what we have here, no? This will be the sample variance, no? For ungrouped data. So that is the sample variance. X for the row score. Of course, the mean for sample mean score or the X bar. Then the N for number of observation. Now, example. So this one, a population variance for group data. A while ago, we have ungroup. So this time, this will be a formula for group data. So almost the same, right? But by this time, we have summation of X. So wherein F is the frequency. Okay? So we have the X, the class mark, of course, the population mean, and the number of observation. Then the sample variance for group data. Of course, we have also sample variance, row score, sample mean score, and the number of observation. Don't forget, this will be the formula for sample variance for group data. Example, find the population and sample variance of the following distribution. So as you can see here, that is an ungrouped data, right? Now, solution. What you're going to do first is to get the mean. Okay? So, X is equal to 34 plus 35 plus 45 plus 56 plus 35 plus 25 plus 40 over 7. So, that is the mean is equal to 267 over 7. So, therefore, our mean or X bar or mean absolute deviation is, of course, 38.14. Then after, how will we be able to get the population variance and for ungrouped data? Okay, so a while ago, we computed already the mean absolute deviation, right? So we get already the 3.18.14. Okay? So if we're going to, for us to get the absolute X minus X bar, so that is X, that is, so X is 34 minus 38.18 or 0.14 rather, that is 4.14. 38.14 minus 35, that is 33.14. 38 minus 45, that is 6.86. 38.14 minus 56, that's 17.46. 38 minus 32, that is 6.14. 38.14 minus 25, that is 13.14. 38 minus 40, that is 1.86. If we're going to sum up, no, the X, that is 267. And our absolute, of course, X minus X bar, that is 1.86. Sorry, no? And of course, for the squared of the X minus X bar squared, that is 606.66. So how do we come up with 17.14? Okay? 4.14 is squared. Since that is squared, that is 17.14. Okay? So it means that 4.14 times 0.4.10, that is 17.14. 3.14 times 3.14, that is 9.86. 6.86 times 6.86, that is 47.06. And so on and so forth. Then 1.86 to 3.46, that is times 1.86, that is 3.46. Now, so as what we have here, we have 606.66 as our total for X minus X bar squared. So for us to get the population variance for ungrouped data, that is direct substitution. So summation, as you can see here, summation of X minus mean value or squared. So that is 606 divide 7. So that is our population variance is 86.7. So how about the sample variance for ungrouped data? So same as what we did actually. So I discussed it already on how we'll be able to come up with this one, this one, this one, this one. Of course, how do we come up with this one and so on. Of course, to get this 4.14 mean it is 38.14 minus 34. That is 4.14 and so on. Then for us to get the 17.14, 4.14 times 0.414 because that is squared. So that is 17.14. Then direct substitution, 606.66 over 6. Why? Because that is n minus 1. Our n is 7. 1, 2, 3, 4, 5, 6, 7. But 7 minus 1, that is 6. So 606.66 minus divide 6, that is our 101.14. This will be our sample variance for the given ungrouped data. Now, example number 5. Compute for the population and sample variances for the data in table below. So, this will be the group data, an example of a group data. Now, I just want to discuss first on how we'll be able to get the x, f sub x squared, fx squared, fx minus x bar squared. For us to get this one, of course, last time, no, we discussed it already, how we'll be able to get the class interval, right? So, assuming that the class is, that the IQ score is 75 to 79, 80 to 84, then 85 to 89, 90 to 94, 95 to 99, 100 to 104. So, the frequency, it means to say that is the number of cases. Now, for this, it means to say that there are 10 students who got 75 to 79, 12 who got 80 to 84, 25 got 25 to 89, 34 who got 90 to 94, 19 got 95 to 99, and 15 who got 100 to 104. For us to get the number of observation or the n or the population or the sample, we just simply add for us to get the f or the frequency. So f, the total n is equal to 115. Okay. Now, how we'll be able to get the x? Okay? So this will be the middle, no? The middle value. Okay? How? 79 plus 75 divide 2. That is 77. 84 plus 80 divide 2. That is 82. 89 plus 85 divide 2, 87. 94 plus 90 divide 2, 92. 99 plus 95 divide 2, 97. 104 plus 100 divide 2, that is 104. Now, for us to get, this time, for us to get the f sub x, we just simply multiply, no? So, 10 multiplied by 77, that is 770. 12 multiplied by 82, that is 984. 25 multiplied by 87, that is 2175. 34 multiplied by 92, that is 3128. 95, okay, 19, no? I multiply by 97, that is 1843. And 15 multiplied by 102, that is 1530. For us to get the x squared, we just multiply by itself, no, the x. So 77 multiplied by 77, that is 5929. Okay, 82 multiplied by 82, that is 6724. 87 multiplied by 87, 7569. 92 multiplied by 92, that is 8464. 97 multiplied by 97, that is 9409. And 102 multiplied by 102, that is 10404. For us to get the f sub x squared, so we just simply multiply this one. So we have f, di ba? F, this will be our f. 10 multiply by 5 by x squared. So that is 59,290. So 12 multiply by 6724, that is 8688. 25 multiply by 7569, that is 189. And so on and so forth. Then if we're going to get this one, for us to get, no, what will be our mean score is 77, right? That is the x. Then x squared. So, f multiplied by x minus x bar square, that is 1876 up to 5854.35. So next. Okay. So for us to compute for the group data sample variance, no? So this will be our formula, right? This will be our formula in getting the sample variance. Okay, so direct substitution, n, that is 115. Of course, our f sub x, no, squared, summation, no? Of course, when we say summation, we are going to add the total. So that is 951,810. This one. Then, of course, the f sub x, as what we have here. A summation of f sub x, that is 10,430. Squared, that is squared, over n multiplied by n minus 1. That is 115, our n is 115. Then 115 minus 1. It means to say that 115 multiplied by 114. Okay? So, group data sample variance, a continuation. So, as what we have here, we discussed it already, this one. So, we may proceed to this one. So, 115 multiplied by 951,810, that is 109,458,150. Okay, this one. Then, 10,430 squared, that is 108,784,900. Then 115 multiplied by 114, that is 13,110. If we are going to subtract this one, no, 109,458,150 to 108,784,900, the result is 673,250 over or divided by 13,110. So therefore, our sample variance for group data is 51.35. Now, we may proceed now to the population variance. Still, we have a group data, the table presented here. Okay? So, of course, we have already the f sub x minus x bar squared. No? So, therefore, direct substitution, the summation is 584.35. So, this one. Then, our n is 115. Okay? So, as what we have here, we discussed it already. So, therefore, our population variance using the available table a while ago, that is 50.91. This will be our population variance for the given table as presented earlier. Now, how about the standard deviation? The standard deviation, or of course, the symbol given, no, as what we have here, or either S, for sample, no? For population, we are using this one for population, and we are using S for the sample. Okay? Is the square root of the value of the variance. So it means to say that that's why we discuss first on how we'll be able to get the variance for us to get the standard deviation. Easy. So this will be the formula for sample or for population and standard deviation, and this will be the formula for sample standard deviation. Example number 6. Compute for the population and sample standard deviation for the data in data table below. In table below. So same, no? Same as what we have here. We have 75 to 79 as our IQ score. I discussed it already on how you'll be able to get the F multiplied by X, that just multiply 10 times 77. We discussed it already, that's X squared. For us to get 82, for example, times 82, that is 6724. The F sub X squared. So what we're going to do is just to multiply, for example, 19. Multiply by 9409, that is 178771. Okay, then, of course, F multiplied by X minus X bar squared. Okay? So, we just simply total the N. That is the frequency actually. The F sub X, of course, that is 10 for 30. Our F X squared, that is 951810. And our F sub X minus bar squared, that is 5854.35. So, to get the population per population, na deviation. Okay, so therefore, square root of 50.91, that is 7.14. How about the sample standard deviation? We get it already, the variance is 51.35. So, the square root of 51.35, that is 7.17. So, it's too easy for us to get the standard deviation if we have a variance deviation already. Okay, proceed. Another example. This time, I'll give you a student score, no? In a practical research one. So, as what we have here, we define already the class interval, no? So, 27 to 29, 30 to 32, 33 to 35. Again, so what is F? That is frequency. So, it means to say that 27 to 29 students or 12 students got 27 to 29. 23 students got 30 to 32. 60 students got 33 to 35. 45 students got 36 to 38. 51 students got 39 to 41. 75 students got 40 to 45. 42 to 44 rather. 28 students, no, got 45 to 47. 33 students get 48 to 50. 18 students got 51 to 53. And 10 students got 54 to 56. Again, for us to get the N or the frequency, we just simply total, no? So 12 up to this one, that is N is equal to 355. Okay, how about the X? Why do we need to find the X? It's already the X, so no need for us to find. Just kidding aside. Na It's just for you to relax. Maybe some of you are now saying, oh, Doc, what will happen? We're stressed. No. Okay, now, how about the x? Where do we get the x? That is the midpoint. Okay? So when you say midpoint, so 29 plus 27, that is 28. Actually, we could able to solve naman in our mind. Because the middle of 30 and 32 is 31, right? But, of course, for a big value or for a big numbers, no? What we're going to do is to add and divide by 2. Okay, for us to get the midpoint, right? That is the point. Okay, the middle of 33 and 35 is 34. 38 and 36, that is 37. 39 and 41, that is 40. 42 and 44, that is 43. 45 and 47, the middle of the 40 and 47 is 46. The midpoint of 48 and 50, that's 49. Midpoint for 51 and 53 is 52. And the midpoint for 54 and 56 is 55. Now, for us to get the summation, the fx, we just simply multiply, right? As I mentioned and discussed earlier, no? So we just multiply 12 multiplied by 28, that is 336. 23 multiplied by 31, that is 713, and so on and so forth. Then if we wanted to get the summation of f sub x, we just simply add, no? So this, if you're going to add this one, the total is 14,410. Then again, for us to get fx squared, so what we're going to do is to multiply this one, no? So f multiplied by 28, of course. 28 times 28, then times f. Okay. So, for example, 28 times 28 times 12, that is 9408. Okay? 31 multiplied by 31 multiplied by 23, that is 22,103. And so on and so forth. Now, for us to get the mean, based on the given, so therefore, f sub x, summation of f sub x over n. So our summation of f x is 14,410. Then our n is 355. So therefore, our absolute mean is no other than 40.59. Okay? Because, of course, don't forget the formula in getting the mean absolute deviation. Okay? That is summation of fx over n. Then, of course, we just simply divide, no? 14,410, 14,410 divide 355. That is 40.59. So, since we have already a mean, no? We have a mean already. So, therefore, we may proceed to get the standard deviation. Okay? So, based on the given formula, our n, a while ago, that is 355, right? Our summation of fx squared, that is 600,154. And our summation of fx squared, that is 14,410. No? The summation of fx, that is 14,410 squared. Then, of course, the n is 355, and minus 1, that is 355 minus 1. So, as what we have here, no? So, if we're going to subtract 213, 054, 670, minus 207, 648, 100, over, that is, no? Just only copy paste, no? That is 125 over 670. For 355 multiplied by 354, that is 125,670. Then, This one, if we're going to subtract this value, no, this one to this value, the result is 5,406,570. Divided by 125,670. So therefore, our standard deviation is 43.02. Or no, our variance, no, standard variance. That is 43.2. So for standard deviation, so direct substitution 43.02 square root, of course, for us to get the square root, that is 6.56. How about the coefficient of variation? It is a statistical measure of the dispersion of data point in a data series around the mean. The coefficient of variation represents the ratio of the standard deviation to the mean, and it is useful statistic for comparing the degree of variation from one data series to another, even if the means are drastically different from one another. So we need to take note that the coefficient of variation formula or calculations can be used to determine the deviation between the historical mean price and the current price performance of a stock, commodity, or bond relative to other assets. So what are the key takeaways for this coefficient of variance? So the coefficient of variation is a statistical measure of the relative dispersion of data points in data series around the mean. In finance, the coefficient of variance allows investors to determine how much volatility or risk is assumed in comparison to the amount of return expected from investment. And the lower the ratio of the standard deviation, the mean return, the better risk-return trade-off. Take note of it. Now, to compare the variability of two or more groups, the task is easy if means are the same. Example, you can easily compare which group is more varied in height between the following groups. So, as what we have here, group 1 mean is equal to 156 centimeter and the standard deviation is equal to 6. For example, the mean in the standard deviation is given, or are given, sorry, or were given. So, for group 2, mean is equal to 156 centimeter, the standard deviation is 10. So, therefore, based on the given, no, clearly, one can say that group 2 is more varied because it has a higher standard deviation. The task become more difficult if the means are not equal and the units are different, such as when comparing the weights of two groups belonging to the different age brackets of different genders. So to compare the variability of the weights of 9 girls having a mean weight of 100 pounds and a standard deviation of 5 with that of the weights of 12 boys having a mean weight of 160 pounds and a standard deviation of 8, a statistic called the coefficient of variation could help you. So the formula, of course, for the coefficient variation is this one. So standard deviation over mean multiplied by 100%. So since standard deviation and mean have the same units, their units will cancel out, and so coefficient variation has no unit. So example number 8. Suppose two groups of students are to be compared in terms of height. So again, we have a standard deviation over mean. So since since standard deviation and mean have the same units as what we have here, their units will cancel out, and so as I mentioned earlier, the coefficient variance has no limit. Now, based on the given here, no? So male, that is 10, no? 10 centimeter. That is the standard deviation, right? So direct substitution. So 10, then the mean is 162. Multiply by 100%. So 10 over 162, that is 0.067. Multiply by 100%, that is 6.17 for male. Now, the coefficient variation per male based on the given mean height and the standard deviation, that is 617. So therefore, that is 6.17. Excuse me. Now, how about for female? So for female, same standard deviation divided by the mean. So female, that is 4, right? 4 centimeter, the standard deviation. And the mean height, that is 148. Okay? So multiply by 100%. So 4 divide 148, that is 0.027. Multiply by 100. Therefore, the female coefficient variation based on the given mean height in standard deviation is 2.70. Okay? So that is 2.70. Okay? Okay, so example number 9, compare the variability of the heights in the weights of the students in Holy Face of Jesus Lyceum of San Jose Incorporated given the following. Okay? So, of course, we have the mean, we have the standard deviation, and the coefficient variance. So, from the result, it can be seen that the weights of the students are more varied than the heights. Okay? How about the quartile deviation or the QD? The formula is QD is equal to Q sub 3 minus Q sub 1 over 2. Okay? So wherein QD is a quartile deviation, this one is Q sub 3, sorry. Is a third quartile, and the Q1 is equal to first quartile. Okay, so again, QD is equal to Q sub 3 minus Q sub 1 over 2. This will be the formula for quartile deviation or QD. Now, sample, find the QD of the following scores. That is, of course, ungrouped data as what we have here. So, based on the given, we have 23, 25, 25, 30, 35, 39, 40, 44, 47, 41, and 60. So, Q3 is equal to 3, no? That is 3 multiplied by 11 over 4. Okay? So, TH. So, therefore, 3N over 4, that is 8.25 items. Because, so therefore, if we have 8, so 1, 2, 3, 4, 5, 6, 7, 8. That's why, since that is 0.25 above 8, so that is the 9, so 47. Thus, Q sub 3 or third quartile is equal to 47. How about the quartile 1? That is, of course, N over 4 is equal to 2.75. 11 over 4, or 11 divided 4, that is 2.75. So that is 1, 2, then 75, it means to say that is 3, right? So that is 25. So therefore, quartile 1 is equal to 25. So therefore, a while ago, we get already the quartile, the third quartile, and the quartile 1. So therefore, direct substitution for us to get the quartile deviation, 47 minus 25 over 2. And that is 22 over 2 or quartile deviation is 11. Hence, the QD is 11. Example number 11, find the QD of the car battery lives in 12 in years. Okay? So we have the given that is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So, of course, for us to get the third quartile, or quartile 3, so 3, that is 10, so multiply by 10, that is 30, right? Over 4, that is 7.5. So, when you say 7.5, that is almost 8, no? So, 1, 2, 3, 4, 5, 6, 7, 8. So, that is 3. Now, that is 3. The quartile 3 is 3.0. So, this one, n is equal to 10 over 4. That is 10 divided 4, that is 2.5. So, 1, 2, that is 3. That is 1.5 or 1.6. Na? That is 1.6. Okay? Now, so 30 minus 1.5 over 2, that is 1.5 over 2, or our QD is 0.75. Or our quartile deviation based on the given value earlier is 0.75. So, find the quartile deviation of the following scores in the table below. So, actually, this table is already presented earlier, no? I discussed it already on how do we come up with this. But by this time, we have the cumulative frequency, no, less than cumulative frequency, and we have the class boundaries, the lower and upper boundaries. Now, how do we come up with less than cumulative frequency? So we discussed it already a while ago, and we get 600,154. So the lower boundaries, or the lower bound, for us to get the lower boundaries, we just simply minus, no, or deduct 0.5. 6.5. To get the upper, add 0.5 here. That's why we have 29.5. So 0.5 minus 30, that is 29.5. 32 plus 0.5, that is 32.5. And so on and so forth. Excuse. Now, in the solution, so 355 over 4, that is 88.87. So hence, the lower quartile 1 is 32.5. Okay, and the CF is equal to 35. The interval is 3, and the summation of Q1 is equal to 60. So direct substitution, that of course 32.5. Then this one is 87.75 minus 35 over 60 multiplied by 3. Then is equal to 32.5 plus 2.99 is equal to 35.19. So this will be the quartile 1 for the given group data as presented earlier. For the quartile 3, at 266.85. Hence, our lower quartile, third quartile is 44.5. Our CF is 266. Our interval is 3. And our summation of X, our summation of third quartile is 28. 3. So that is 3.5 this one, 3 is equal to 4.5 plus 0.027 is equal to 40.50.
Din, wala pong sounds ulit. Din, nawala po ang sounds.
Yes po, sir. Nawala po yung sa
Yun lang yun. Sandali lang nga, on and off lang yung aking connection.
Sige po.
Of course, if we're going to subtract, that is 9.34 over 2. So, therefore, our quartile deviation is 4.67. Percentile or the PR or percentile range. It is the difference between the 90th percentile or P sub 90 and the 10th percentile or P sub 10. So, the formula is PR is equal to P sub 90 over P sub 10. Example number 13. The following data represent the score of students in probability statistics final examination in Holy Face of Jesus, Lyceum of San Jose Incorporated. Okay? So, what we're going to do first, as what we have here now, we have 100, 100, so on and so forth. So, this will be the sequence, no? 100, so, no, this will be the sequence. Then, from here, go here, then so on, so forth. This will be the end, okay? So, calculate the percentile range of the score. So, again, P sub 90 is equal to 90 over N over 100. So, 90, so a while ago, if we were going to count the occurrence, no, or the numbers of respondents or the frequency, that is 29. So, 90 multiplied by 29 over 100, that is 26.1. And the item is 175. If you're going to count from 1 to 26, that is 175. Based on the given table a while ago. Then the P sub 10, 10n over 100, that is 10 multiplied by 29 over 100. That is 2.9 no, item, which is 111. No, so therefore, direct substitution, so 175 no, minus 111, this one, the answer is, or our percentile range is 64. So hence the percentile range of the scores given a while ago is 64. How about the percentile for the ungrouped data? To calculate percentile, a measure of relative standing of an observation for the ungrouped data, adopt the following procedure. Of course, again, don't forget to arrange orderly from lowest to highest score. For the M percentile, determine the product M multiplied by N. That is another formula actually, but the same, no? Another variables, but the same. So based on the given value here, we have the data collected from the students to find the 10th and 95th percentile. So what we're going to do is to count, of course, this one, no? So I think that is 30, the total. So the solution, if the professor, or for example, if you are doing research, then right after getting the data, so in an ordered manner or form, what you're going to do first is to rearrange, no, from highest to lowest. So starting from 87 up to 112. So 10, of course, that is P sub 10, that is 10 multiplied by 30, or opening close parenthesis 30, over 100, that is equal to 3. So the 10 percentile is the third observation. So when you say third, that is 88. Na, ayan, no? So 1, 2, 3, that is the third, 88. Okay, so P sub 95, 95 times 30 is equal to 100, or is equal to 28.5. So therefore, instead of 28.5, we make it 29. So therefore, the 29 is 107. Okay? This is the easy way on how to get the P sub 10, P sub 95, and so on and so forth. How about percentile for the group data? So another variables, actually same, no? But different variable. Okay, so this will be the process. as you can see here, no, as I mentioned, different variable, but the same concepts, no? So L is the lower class boundary, no, of the class containing the M, no, percentile, depende, it depend, no? High is the width, F is the frequency, N is the total number of frequencies, and C is the cumulative frequency. So based on the given example, so that is direct substitution as what we have here now. So if we are going to get the P sub 10 or the 10 percentile, so the lower, based on the given value, right, that is 10x times 10 times 30, that's 100 is equal to 3, right? So therefore, since we have 3 here, that is under 85.5, no? The lowest, no? Because the 6, how do we come up with this one, no? 6, that is 6, no? 6 plus 4, that is 10. 10 plus 10, that is 20. 20 plus 6, that is 26. 26 plus 3, that is 29. 29 plus 1, that is 30. Okay? So when we say 3, that is under 6, right? So therefore, the lower limit is 85.5. Okay? So, then direct substitution. So the P sub 10 therefore is 88. So how will be able to locate the 25th percentile? So same as what we did. So 10 times n over 100, 25 times 30 over 100, that is 7.5 observation. So therefore, P25 group is 90.5 to 95.5 containing the 7.5 observation. So we just simply try to get with the table. Okay? Then the P sub 25 or percentile 25, that is 92.375. Then for the second quartiles or fifth decile or the 50th percentile or the median or second quartile of the fifth decile. So it means to say that when you say 50th percentile, that is equivalent to median, or the second quartile, and that is 100 over 100, that is 50 times 30 over 100, that is 15 observations. So therefore, if we are going to look into our table a while ago, P sub 50 is 95.5 to 100.5. So containing the 15th observation based on the result of our computation by 50 n over 100. That is 15 observation. And we're going to count or to look with our table. So therefore that is 95.5 up to 100.5. So therefore, that with direct substitution, so therefore we could able to get the P or the 50th percentile is equal to 98. How about if we wanted to locate 95th percentile? It's just simply 95 times 30, no? Because we have 30 frequency or number of observations. So therefore, over 100, that is 28.5. And if we are looking to our table, 28.5 is under 105.5 to 110.5, containing the third observation. So direct substitution again. Therefore, our 95th percentile is 109.667. But not necessary naman for us to have 0.667. Because it's better to you have the 106.67. And that's it for this topic. This is all about measure of variation. And this will be our references. Thank you for that. And thank you for some researches, some examples, and so on.